Okay, so now we have the dog who wants to participate. So the last one is log base 2 of 3. So I will tell you, I had never seen this proof before. And I thought it was really cool. So I'm glad you thought so too. How did this proof go? Do you remember?
So it's the same concept. What we do is we assume that log base 2 of 3 is rational. And that would say that 2 to the a over b is equal to 3.
Okay.
And we have this a over b power that we can do something with. We know that when you multiply powers, when you raise a power to another power, so 2 to the a over b becomes equal to 2 to the a to the 1 over b, and this equals 3. And then what we do here is, to get rid of this 1 over b on this side, we have to raise both sides to the b power.
Alright.
And that 2 to the a equals 3 to the b. And now, already this is our contradiction, because sort of a simple way to see it is that this side is always going to be even, no matter what a is, and this side is going to be odd, no matter what b is. So these two can never be equal.
Nice. Okay, so just to be clear, a and b are integers.
Yes, a and b are integers.
Because that makes a difference. So 2 raised to any integer power is always going to be what?
It's always going to be even.
It's always going to be even.
Yeah.
And 3 raised to an integer power.
And that's always going to be odd.
That's always going to be odd.
So our original assumption, again, that log base 2 of 3 is rational, that must have been wrong. So we have from that this is irrational.
Cool. So what did you think about this proof? I mean, like I said, I had never seen this one before. I think it's really neat. What did you think?
I thought it was, I'd never seen like sort of a different way of using a proof by contradiction before. This was sort of a different way to do it other than the square root of 2 is irrational proof.
Uh-huh.
And I thought that was cool.
Yeah, I like this a lot. I'm really appreciative for John making this video. All right, good job this morning, Tom.